Okay, I was asked over email to go over a few word problems and talk about, just how do we do word problems. So here's a word problem. The product of two consecutive numbers is 306, and we want to find the numbers. Okay, so the first thing that you're always doing when you do a word problem is you need to do a let statement. And a let statement is how you define your variables. Okay, and you always define your variable based on what you're looking for. So for instance, in this problem, I'm looking for the numbers. So what I'm going to do is I'm going to say, let's let x be the first number. Okay, once you start to put definition to what it is that you're looking at, then the problem becomes easier. Okay, so let's go back and look at it again now. It says the product of two consecutive numbers. Well, my first number is x. If you think about what consecutive numbers do, consecutive numbers are numbers that are in a row. So for instance, if I look at the number 5 and the number 6, these are consecutive, right? And if this is my x and I have to think about what did I do to this 5 to get up to a 6, actually what I did was I added 1. Okay, so when we're talking about consecutive numbers, sorry, that's okay. When we're talking about consecutive numbers, what we're doing is we're actually adding 1 to whatever our variable is. So, if I want to go from this number to this number, I would actually just add 1. The same is going to be true if I'm doing this in the abstract form. Okay, so if x represents my first number, then x plus 1 is actually going to represent my second number. Okay, all right, so then if we go back and look at it, it says the product of two consecutive numbers. So this is representing, these two are representing our numbers. The product refers to multiplication. So if I take x times x plus 1, that's actually going to represent the product of two consecutive numbers. Okay, and then it says is 306. So in math, is always an equal sign. So we have is here. It's going to be an equal sign, and then we're setting it equal to 306. Okay, once you have the problem set up, you're done with the word problem part of it, and you're actually just solving this. So we would say, well, this is going to be a quadratic. The only way to solve it is to set it to 0. So I'm going to take my x and distribute. So this is going to become x squared plus x equals 306. And then I'm going to subtract the 306 from both sides. So I have x squared plus x minus 306 equal to 0. Okay, at this point then, I want to factor this. Okay, so I'm going to use trial and error. I'm going to use an x and an x. And then for 306, if you use your calculator, eventually you'll end up finding that 18 times 17 actually give you 306. And if I put a plus sign here and a minus sign there, then that will work. The outside inside would add to give me a positive x, and if I check the last here, negative times positive gives me negative. Okay, so I'm going to set x minus 17 to 0 and x plus 18 to 0. And if I solve these separately, add 17. So I get x equals 17, and here subtract 18. And I get x equals negative 18. Now, these are actually both solutions because they said to find the numbers, but they didn't say that the numbers had to be positive. And so, if I take a look at 17, if 17 is one of my solutions, then a positive 18 will be the number that will go with that. Because if I add 1, if I took my 17 and added it back in up here and added 1, I would get 18. And with the negative 18, with this negative 18, if I plug that in up here and add 1, I'm going to get a negative 17. So the number that's going to go with that would be negative 17. So you actually have two solution sets here. You've got positive 17 and 18 and negative 17 and 18. Okay, so that would be that word problem. And then wanted to do another example, a word problem would be this one right here. We have the area on a triangular mainsail of a sailboat is 161 feet squared, and then the height of the sail is 9 feet more than the base of the sail, and we want to find the height and the width of the sail. Okay. All right, so the first thing that we have to take note of here is that we're actually dealing with the area of something that is triangular. So we should first of all just get in our minds that the area formula for a triangle is 1/2 base times height, when my base is this distance right here and my height is that distance right there. Now, I've actually drawn a right triangle there. It doesn't, the area formula applies to any triangle. If I had a triangle that looked like this, then my height would actually just be this distance from the apex, this is called the apex, down to the base. This whole thing would be called the base here. Okay, so regardless of what type of shape you're looking at, the area is always 1/2 base times height. Okay, so we're going to be working with that. Okay, and then we should try and give ourselves a picture here based on the information that they've given us. So they're saying that the height of the sail is 9 more than the base. Okay, well, if I draw myself a picture, if I just let my base be B, and they're saying that the height is 9 more than that, then the height would actually have to be 9 plus B. And the reason that I'm trying to represent this just in B is because I need to have one variable. I need to have this just in one variable in order to solve it. Okay, so my height here is actually going to be represented as 9 plus B. The other thing that they tell us is that the area is actually 161 feet squared. So this value, 161, is actually going to go into my formula for the A. I have a value for the H to plug in as well, and that's B plus 9. Okay, so when we plug these in, it's going to look like 161, and that's my A, equaling 1/2 of our base times our height, and the height is represented as B plus 9. Okay. All right, at this point then, it's just a matter of how do we solve this. And, you know, the first thing I would want to do is just distribute the 1/2 B. So we have 161 equaling 1/2 B squared plus 9/2 B. And anytime you're dealing with fractions and you're trying to solve, it's probably easiest to just clear the fraction. So what I would want to do here is find the common denominator for every fraction in the problem, and then multiply everything in the problem by that common denominator. So you can notice in this problem the common denominator is a 2, so I'm going to go ahead and multiply both sides by 2, and that's going to effectively get rid of that fraction. So 2 times 161 is going to give me 322. And then when I distribute the 2 here, it's actually going to cause both of these to go away. So 2 times 1/2 is going to just give me B squared, and 2 times 9/2 is just going to give me 9B. Okay, so what I'm left with is something that doesn't have a fraction. Okay, again, this is a quadratic, and the way that we're going to solve quadratics is by setting them to 0 and then factoring. So what I'm going to do here is subtract the 322 from both sides so that I have B squared plus 9B minus 322 equal to 0. Okay. Okay, so at this point then, we want to try and factor that. And again, 322 is a large enough number that you're just going to have to play around with it on your calculator. And I guess maybe I should go into that a little further. When I say play around with it, you just start dividing numbers into it and see what you can get. So, you know, for instance, start with a 2. It ends in a 2, so you know it's even. So it's going to be divisible by 2. If it's divisible by 2, it'll probably be divisible by 4 or some other multiples of 2. And when you play around with it, you'll end up finding in this problem 23 and 14 end up working there. And if we make this positive and this negative, the outside, the inside would give me a positive 9b, and if I check the last, negative times positive will give me a negative 322. Okay, so now I'm going to set b minus 14 to 0 and b plus 23 to 0. And when I when I go to solve this, add 14 here to both sides, and I get b is equal to 14. And over here, when I subtract 23, I'm hoping that you understand that this doesn't make any sense, because we're talking about, the area of a sailboat. This representing the base of the area of a sailboat, and having a negative base makes no sense. So we would actually eliminate this as an answer. And so our base would actually be 14, and then we want to add our units back in here, 14 feet. Okay, and then I did ask us to find the height and the width. The width here is going to be our base, and then the height, if we go back and look up here, our height is defined to be 9 plus the base. So if I just take my if I just take what I found for my base and I plug it in here, then I'll find that the height is 9 plus 14, or in other words, 23 feet. Okay. And I guess actually one other thing I did want to say about this problem. You notice in the previous problem, what I did was I had us actually define variables here. Let x equal something, and then defined whatever else we were working with in the problem. And that's very, very important for you to do if you aren't working with a defined formula. And the reason I didn't do that in this problem is we were working with a defined formula, area equals 1/2 base times height. A, B, and H here are already defined, so I didn't have to do a let statement. Okay, so whenever you're working with a defined formula, you don't have to define anything, but if you're not, then you do, and that's an important part of these problems.